Well, hello there. All right, so we are back. It's video 3, and we're working on arithmetic partial sums. So we're still in our sequence units, and we're still sticking with arithmetic sequences, but this time we're going to be looking at summing all of the numbers in our sequence. And I say partial sums for a reason. And that's important. We'll take a look at in a second. So we're going to be finding the partial sum of an arithmetic sequence, and we're also going to be working backwards. When I give you some information, we're going to be looking at it from a different direction. So kind of similar to what we've been doing in class, and going from a backwards standpoint. Okay, so what we're going to be talking about with partial sums is because when I have a sequence, and let's just pick a basic one here, nothing too complicated to think about, is that these numbers are going to continue to get larger. So if I want to sum them, as in add them together, and I start adding these numbers, all of a sudden, I mean, just by adding these right here, I'm already at 30. So if I add another 3, then I'm at 45, and I add another 3, and so I'm constantly at 63. I mean, that's just getting big really fast. So if I were to add this dot, 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 I mean, the number is going to be infinitely large. So I won't be doing an infinite sum. So when we do arithmetic sums, we will never be working with infinite sums because they go off to infinity. In fact, we can actually talk about that as end behavior. And not graphically or anything else, but the end behavior of this sequence is positive infinity. That's where it's headed. But when we talk about partial sums, I'm talking about finding a sum from the first term through whatever term we're interested in. So if I write S sub 15, I'm talking about the sum of the first 15 terms. In other words, I want you to add a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub 14 plus a sub 15. And this is a notation that says you're going from the first to the 15th. This ellipse in the middle says you're just going to keep adding. So that's what I'm interested in doing here. Well, there's two formulas that we can do this, and they're very much related. The first one I'm going to give you is going to look the most complicated, and to be honest, it's the one you're going to use the most frequently. Then there is a shorter hand notation for this. So actually, I'm going to give it in the reverse. I'm going to give you the shorthand one, and then I'm going to show you the longer one. So I have S sub n, n being how many terms do you want? I don't know, 10, 20, 100, equals n divided by 2 times the first term plus the last term in your sequence. So if you're looking for the 15th, the sum of the first 15th term, or the partial sum here, I would have a 15 here, I would have a 15 here, and I would have a 15 here in notation. Then I would substitute those values in. But what if I don't know the 15th term? Well, then I'm going to be using the second version of the same formula, which says, well, then we better actually fill in what this a sub n really means. So it's a sub 1 plus, and what is our definition of a of n? Well, that would be a sub 1 plus the common difference times n minus 1. So this is just my a sub n. That's all that is just being replaced. So you have two different versions of the exact same thing because I'm replacing it with another definition. You could clean this up, and this is how you'll actually see it written most often, is that now that I've got this in here, I can combine like terms and say I have two a sub 1s plus the common difference times n minus 1. I don't really care which one you use, but you will probably be using this second version the most. So let's use it. So I want to find the partial sum of the first 24 terms if given the arithmetic sequence with the first term being 4 and the 24th term being 454. So in this case, I was already given the first term and the 24th, and I want to be able to sum all of the numbers in between them. So instead of adding them up on a calculator, we're going to use this quick method. And it's going to be that the partial sum of the first 24 terms is 24 divided by 2 times 4 plus 454. Oops, I got carried away with my numbers there. Okay, so I simply have to evaluate that in my calculator. So I'm going to give you a second to go ahead and try to evaluate that on your own. Careful with the parentheses and such. And you could do a little simplifying beforehand, like calling that 12. And my answer for summing in this sequence the numbers between the first and the 24th terms is 5,496. All right, the next one. So I want to find the sum of the first 53 terms. Again, I'm given the first and I'm given the 53rd. So I'm lucky in this case I get to use the shorthand formula. So the sum of the first 53 terms is equal to 53 divided by 2 times negative 3 plus a negative 257. So go ahead on your own again and try that one. All right, so I ended up with negative 6,890. All right, very good. Okay, so this is a little bit of working backwards. So, or maybe not working backwards, but I don't have the same amount of information. It's not a working backwards. So I'm going to begin here with saying I want to find the sum of the first 16 terms. I have the first term. I don't have the 16th term. So we can do one of two things. I can use that second formula where I have the sum of the 16th is going to be the 16 divided by 2 and a sub 1 plus a sub 1 plus d times n minus 1, okay? And I can substitute in all of my values because I have every one of those values. Or this, we could just find this 16th term and then use the formula we used in the previous two examples. Completely up to you. I kind of like this because I don't really have to do any extra work and then try to substitute it back in. So it's going to be s sub 16 will equal 16 over 2 times the first term plus the first term, plus my common difference here is 2 times 16 minus 1. So this really is my 16th term, but I don't have to calculate it separately. So I'll just go ahead and keep simplifying this. 8 times 18 plus, this is going to be 15 times 2 plus 30, so that's going to be 8 times 48. Of course, you can do that all on your calculator, or you can do it in pieces like I did. And you're going to get 8 times 48 to equal 384. So if you add up the first 16 terms in this sequence, you'll get 384. Okay, so now we've got some working backwards problems. I'm actually given here the sum, the first term, but I need to find the 30th term. Well, luckily my sum and my number match, so I can go ahead and use that first formula. I'll write that first formula up here. And we're going to substitute everything into it except a sub 30 because that's the thing I don't know. So now you're saying, well, what's n? Well, n is the 30 because it matches in both places here, or all three places. So I'm going to have 1875 will equal 30 divided by 2 because that's the n that I've got, times my first term plus the one I'm looking for. So here you're just going to be very careful using your calculator to solve for a sub 30. And let's give it a whirl. So I get 125 when I move this to the other side because I just divided by 15 since that's what that represents. 6 plus a sub 30. And then we'll subtract 6 and we get a sub 30 to be 119. So to check this, we could of course substitute it back into our formula up here and see if we end up getting 1875. Okay, here's another one. I want to find n this time. So I've got a first term, and I've got the nth term, and I've got the sum of the first n terms. So these n's are actually the same n, which is important to know so that I can work very similar to the way we had up here. So I've got negative 125 will equal, I don't know how many terms I'm adding together, divided by 2, plus 19 plus a negative 29. The reason I can do that is because my a sub n matches the n, which matches the s sub n. So this n really represents the same thing. So I'm simply solving this. This is going to give me negative 250 will equal n times, and then, because I multiplied by 2, and then this value in here is negative 10, so we'll divide by negative 10, so I'm actually adding the first 25 terms to get this particular situation. Please keep in mind that n has to be positive. N represents the number of terms you've got, and we have to have a positive number of terms. Your answer will be 100% wrong if you give me a negative n value, because it doesn't make sense. Alright, so we've gone through a few things here. We've used our explicit and recursive definitions, we've used our partial sums here, and then we've gone ahead and worked backwards to find these with our partial sums. So keep a few things in mind. N has to be positive, and when you choose an n, you're actually using that n in multiple places. You're talking about the partial sum value, you're talking about the term value, and you're talking about the number of terms that you have. And then we also talked about how you could really choose between either of those formulas to work with these. Bring any questions that you have to class.